Hi fellas, how are you today? Are you okay? I really hope so. Today we are going to talk about something different. We are going to explore the data science. In this case, we are going to use the abalone.csv. We have some datas and it's quite big, as you can see. And abalone, it's a marine mollusk shellfish. It's very expensive if you buy to eat. It's one abalone, like 200 grams, costs such as $50. Okay, and it does live about 40 years, and it's very popular gastronomic food. Okay, so let's explore this data. So we are going to create our Python abalone.py. I'm closing this file, and the beginning we are going to use the descriptive analysis. We need to know if the data is correctly, if something is empty, and if you need to make any configuration. Let's start with the pandas. Import pandas spde. We are going to use Seaborn, either import Seaborn as in S, and to watch the data on the graphical, you are going to use the Matplotlib. Import matplotlib.pyplot as plt. Okay, save. Data frame, what is it? PD to use the pandas and the function read, and I am going to call the file abalone.csv. Print df, execute. There's the data. It starts on the 0 and ends up with 400. And now we are going to explore some info with the .info. And we can see that we have 9 columns starting with the 0, and all the values is null, and then we don't need to fix anything. And the data, we have this much, 4,177 datas. Okay, that's a lot of data to explore with the Python and the data science. Now let's go use some Seaborn. SNS pair plot, data frame. I need the names of the columns, then I can use the columns here to watch what is inside columns. Print, and I will copy it to make it more easy to explore the datas. Okay, and I comment this line. Let's get back to info. Now I'm using df. Let's explore the height. No, better. Let's explore the length. We need to use one list inside another one when you are using more than one column. Then we use the length. Let's use either the diameter, the height, and the rings. I'm ignoring the weight, okay? Weight data. We are going to explore it furthermore. For now, we are going to use that one. Okay, I'm using the par plot. Now I need to watch on the graphical with the PLT. So it's pretty easy to use PLT dot show and print. There's the data I have printed. There is it. Let's get it. There is it. The length, diameter, height, and rings. And even here, the same here. As you can see, we have some outliers, like that and that point, that. It's looking so two outliers to explore. In this graphical, we can see it's the height and the outliers have the value, such as over here is the value on the mouse is up inside, and that one the value is 0.5. It's upper than 5, and that one is 1.1. What we can do to remove this outlier from this data, we can use we can filter it. I'm filtering with the df data frame. I'm filtering the height, and I'm calling minus equal 0.5. Now I have to change the data frame. Let's see if it does work properly. I'm running again. There is it. Those two datas is out now. Now we can watch it with the better way. Okay, let's use one more, the histogram, plot. Keep with the data frame, and I'm going to explore the length. KDA, it's true. I'm calling to the graphical the line to run with the histogram. Okay, let's explore the first one, graphical. We already have explored it. I'm closing. The second one comes above, and the most data, it's between the 0.6, and it have such as 300 datas over here. And then it's the maximum data with this value. Okay, we saw some data with the histogram and the pair plot. Now we are going to use the Scikit-learn, and we are going to explore the linear regression, multilinear regression. Okay, so we don't want to print every single time those graphicals. I'm going to comment it, and we start with from sklearn dot model selection import train test split. I'm giving the nickname like we did on the another libraries as TTS. Okay, I'm creating two functions, the x in the uppercase. It's common used on the data science, the x in the uppercase. Okay, data frame. Now I'm calling more than one data on the columns, and then I'm using two lists. Now I'm going to take the height, and we are going to paste here, and the y it's to analyze the x and the y, and the y I'm calling the data frame. We are going to explore the length. Save the train test split. If you watch inside it, you can see how it's the examples, how it's going to train and test the datas. So let's copy it with the Ctrl+C. Let's Ctrl+P here. Give the nickname TTS. What we are going to do in that lane, the x train and the x test size, it's 32% of the data, and then the x train going to be the 66th. Okay, and the random state, usually the data science keeps with the 42, but I'm going to use the 62. Save. Now we are going to use the linear regression. sklearn linear model import linear regression SLR. I'm giving the nickname again. Now we gotta to create the variable to call the function. The variable I'm calling it model. Now I'm call the linear regression and make it the function. Okay, model fit x train and the y train. We are training the algorithm with the sklearn, and it's using the abalone data. Let's explore the intercept. Model intercept and print it, and there is it. Let's mix on jump this data. There is it, the intercept. What it does mean 0.33. It means when the columns here, when the columns weight be 0, the length gonna be 0.33. Okay, that's the meaning of the intercept. Let's explore another one. Let's jump it and print model and the it's the coefficient. Okay, and it's giving me 1, 2, 3, 4 datas. These datas, it's above the height, the weight. Let's make some illustration to you see more. Let's call CDF. I'm calling the data frame model coef again. X, I'm calling the X columns. With the columns, I'm going to call it the coefficient. Okay, now we print it. There is it. The coefficient of the weight, the whole weight, and the shooked weight, visceral weight, and shell weight. Okay, but what the fuck does it means? Man, I will tell you. It does mean for each 1 unit of the whole weight that increase, the length going to increase 0.02, and for the 1 unit that increase of the shocked weight, the length are going to increase 0.15, and so on. That's the meaning of the model.coef, the coefficient. So our data is good, it's bad. How to know if it's efficient to explore the data and the result the linear regression is giving to us? I'm show you 2 ways to explore it. Let's go for it. Let's code it from Scikit-learn metrics. We are going to use metrics to watch if the result is efficient. Import mean squared errors and R2 score. Okay, it does says it's deprecated, but it's are going to keep working at least if you are coding with me in this version Python. Let's make the prediction. The ypred, it's the model dot predict, and we are going to call the X test, and we are going to make the calculate with the R squared. Okay, we are going to analyze the determination of the coefficient. Okay, and the R2 score, Y test, what I have done above, and with the Y predict. Print. This result is the R squared, so I'm calling the R squared is the result is the R squared. Let's print. Something's going wrong. What is it? Let's jump it. There is the result of the r squared. What the fuck it means, man? Chill, Paul. I'm going to tell you what the r squared means. Be easy. This r squared means that 87% of the length variation, in this case the coefficient, it can be explained with the columns data, the weight columns data, okay? And then we are going to say, in other words, that 87% of the chance of this coefficient it's correctly, and its height values. So now we can see the data is pretty well. We have used the R2 score. Now we are going to use the mean squared error. So let's go for it. Now we need to use numpy either, so let's import numpy as np, the nickname rmse numpy squared. Now I'm calling the variable, and we are going to use the y test either and the y prediction, like we did on the R2 score. Same thing, but for the mean squared error. Let's print the result. Jumping this information, print fmse. What the fuck does mean? It's the root mean squared error. Okay, that's the meaning. And we call the result. Let's print it. And there is it. Okay, Paul, what the fuck it does mean? Chill, man, I'm going to explain to you. It does mean that the error of the prevision is very little, with the 0.04. It's the average calcul to assume the error. So this code shows the efficient percent of the data we have analyzed with the linear regression, and RMSE, the root mean squared error, shows that as little the result is, it's show us that the analysis is going well, and we have 87% of the precision of the analysis, and the error is about 0.04. So there is it, man. We have explored the abalone.csv data. That is what data science does, man, with the Visual Studio Code. Okay, that's some example. Just we can explore so much more. It's a large tools to explore, but we are going to keep it for now, like we have did. Okay, I hope you have enjoyed, fellas. That's all for now.